Thank you, Michelle. Good afternoon, everyone. As Michelle has already introduced, my name is Anne Keyes and I'm Secretary of the Heath Group Water Scheme, which is located in Portlaoise. I'm extremely overwhelmed and very nervous to be talking to you all here today amongst such learned, qualified people, so please bear with me. I was invited to talk to you today on foot of our scheme being the inaugural winner of the Federation's Excellence Awards in 2021 in the category of Water Safety Planning and Quality Assurance. I would like to take this opportunity to thank the Federation for setting up these Excellence Awards and for acknowledging the hard work schemes put into their operations. I'm sure you will all agree it is not an easy task. I was roped into becoming the position of Secretary in 2002 by my late father, John Keyes, who was one of the founder members of our scheme. He assured me it would just entail taking minutes at a board meeting once a month and writing a few letters. And I'm sure you're all well aware how that workload has grown. Now, a little bit about our scheme. Our scheme is a private group water scheme and it's located about 5 kilometres outside of Portlaoise in County Laois. The scheme was originally set up in 1964 with an initial 40 connections and has grown since then to a current membership of 408. Of these 408 connections, 313 are pure domestic, 39 mixed domestic, and then the balance comprises land, farm, commercial, community, and 1 primary school. As I'm sure you'll all agree, the most important factors with regard to water are quality, quality, and quality. To this end, we, in our scheme, have identified 5 critical control points to monitor and control this quality. The first critical control point for water quality is the actual water source. The scheme's water source is a spring which is fed by groundwater from a karstified limestone bedrock aquifer. That's a bit of a mouthful. As the terrain in the heath is permeable, the rainwater filters down until it reaches the main body of groundwater located within the bedrock. The land in the catchment area of the scheme is predominantly used for grazing, silage production and tillage with pockets of coniferous forests. There are 2 working farms in the catchment zone of the scheme and thankfully they are very vigilant about their farming practices. We had a comprehensive zone of contribution study carried out in 2015. This study gave the scheme invaluable information about the terrain surrounding the spring and it gave us invaluable information as to our water source and identified any areas of concern in the contribution area. The scheme continues to identify and map the potential contaminant hazards and activities within the zone of contribution, ever fearful of a negative impact on its water supply, its water quality. Extraction point and pump house. The second critical control point is the abstraction and treatment plant. I'm going to take these 2 points in tandem as they work together. The spring and purpose-built chamber pump house are located within a fenced site and the spring source is located next to the pump house in a purpose-built spring chamber. The chamber is fitted with a lockable steel covering. There is also an overflow chamber located about half a metre below ground level. This is a V-notch chamber and the excess water which overflows from the well flows out and away into a nearby river. The volume is monitored by a flow valve system and this data is stored on a hosted cloud. There are 2 water pumps installed in the pump house. Sorry, I'm gone a bit behind on my slides. There are 2 water pumps installed in the spring chamber and they pump the water to the reservoirs alternately. The scheme does most of its pumping at night to avail of cheaper electricity rates, if such a thing exists anymore. The duty pump can also kick in during the day to keep the reservoirs topped up. The water is treated before leaving the pump house using a dual chlorine system. That's our very happy caretaker there, looking after the chlorine. The scheme uses 78% strength chlorine for its water treatment. The water pumps and chlorine pumps are fully automated and can be monitored remotely using water monitoring software. If the duty water or chlorine pump fails to kick in, their standby counterpart will start up. The chlorine dosing pumps in the system are flow proportionate. The dose rate for the system is based on a predetermined pattern, and manual adjustment of dosing can also be carried out if necessary. As I mentioned earlier, the water and chlorine pumps can be monitored remotely using cloud technology. Those with login permission can view which pumps are running, the capacity in the reservoir, the chlorine pH level, turbidity, to mention but a few. This website is updated on an hourly basis. Slide 9 depicts that at the particular time the photograph was taken, water pump 1 was the duty pump and pump 2 was on standby. We can also see the pressure and reservoir levels. Acceptable levels for each control were set following discussions with our engineers and service providers. If any of the set levels are exceeded or not reached, the relevant personnel receive either a text alert or an email from our service provider to advise that there is an issue. Slide 10 illustrates the type of email notification we receive. In this case, you can see that on the 17th of July 22, we received a notification at 18:24 to advise that the reservoir level had dropped below the accepted set level of 0.49 metres. All equipment in the plant is serviced twice per year by appropriately qualified contractors, and all chlorine monitors are recalibrated at about once per month and again after a power outage by our caretaker. Our caretaker has a QQI qualification in water treatment plant operations to enable him to carry out these calibrations. Full PPE gear is supplied in the pump house, and a safety statement and accident report register are also maintained in our pump house. We then move on to critical control point number 3, which is our reservoirs. Once the water is treated in the pump house, it is pumped to 2 reservoirs which are located atop a hill about 1.5 kilometres away from the pump house. The reservoirs have a capacity of 95 and 190 metres cubed respectively, and they are located on a fenced, locked site. Each reservoir has a max depth capacity of 3 metres, and when the reservoirs reach a capacity of 2.6 metres, the water pumps cut out. Slide 12 is an example of the bulk meter in our pump house. This bulk meter measures the volume of water which is pumped to the reservoir every night or day. The reservoirs are checked both internally and externally on a regular basis for cracks, seepage, etc. In 2018, the scheme received capital grant funding to install a new chlorine monitor which tests the water as it leaves the reservoir before it reaches any consumer. The data from this monitor is fed back to the pump house and also available to view on My SCADA Cloud. Our caretaker also manually checks the chlorine levels in the treated water on a daily basis with a handheld HAC calorimeter. Again, he also calibrates the chlorine monitor at the reservoir at least once a month. The scheme has identified the distribution and pipe network as critical control point number 4. We currently have over 40 kilometres of pipe network, about 80% of which has been replaced in the last 10 years, and we were hopeful that we will receive further funding in the next programme to replace the remainder. The scheme network is divided into 8 districts, and each of these is allocated its own bulk meter. Bulk meter 1 is the main bulk meter which measures the total volume of water going out into the network. Some of the 8 districts are further subdivided into smaller areas, and each of these has a mini bulk meter assigned. There is a further chlorine analyzer located in the middle of the network, and again the data from this monitor is fed back to our pump house. The scheme has several sluice valves installed across its network. These are used to control the flow of water through the pipe network, and they can also act as a shut-off to isolate the supply. Scour valves are also located at low points or between valved sections of the pipeline. They allow periodic flushing of the lines to remove sediment and to allow the line to be drained for maintenance or repair. This slide depicts one of the lines being flushed. The caretaker flushes the ends of the lines about once per month, and we also have several fire hydrants installed across our network. Our scheme always uses the same contractor to carry out our connections and repairs. All works are carried out on the road are covered by the appropriate road opening licence. A map of the complete network and all the connections is available for reference in our pump house. The fifth critical control point is the automatic shutdown of the plant. The auto shutdown of the plant and the upgrade of the monitoring system means that the plant will shut down if any of the set control points are not reached or exceeded. This auto shutdown system gives great peace of mind to the scheme, whereby if an issue occurs, the plant will shut down and avoid any contaminated water reaching the reservoir and thus the membership. Again, the auto shutdown will automatically trigger a notification to alert relevant personnel that there is an issue. In addition to the 5 critical control points above, the scheme also places great emphasis on a few other important factors, one of which is technology. All the systems in the pump house are automated and can be monitored remotely on host sites. The scheme has 2 systems in place to monitor the consumption on its bulk meters. The first system which the scheme has installed is a web-based data collection and management system which provides live access to all the bulk meter readings. In 2018, the scheme received capital grant aid to install another web-based data collection system for reading the bulk and the consumer meters. Every bulk and consumer meter on the scheme is now fitted with a transponder, and the scheme has a handheld reader, which means the caretaker can drive around all our connections and pick up the latest meters telemetrically. These readings are then uploaded to a cloud-based system and we can extract data from same. Now, this is a little bit blurry. This is a slide of one of our bulk meters, and you can see the little bars on the graph indicate the levels of consumption, and it tells us when it was read and the average consumption which goes through the meter every day. Slide number 20 is a copy of my meter readings. As you can see the dates the meter was read and the resulting reading on that date. It also gives an indicator as to whether my consumption has increased or decreased, and you might be able to see the tiny little yellow arrow which indicates that over that period of time my consumption had increased, but in my defence I never went over the free allocation. Once the readings have been uploaded to the cloud, they can then be downloaded in the form of a data spreadsheet and used for billing purposes. As already mentioned, the scheme also subscribes to STADA Cloud, which is an internet-based control and monitoring system which enables the scheme to fully monitor and control our water treatment and water pumping system. In addition to the online monitoring, our caretaker visits the pump house on a daily basis to record readings manually and to visually check our pump house. The scheme engages the services of Fingleton White Engineers Portlaoise, who keep us abreast of advancements in technology in the water services industry. The scheme has also set up a free text alert system whereby we can update our membership instantaneously of water outages, meetings, etc. Ongoing monitoring is another important factor. As part of its water safety plan, the scheme engages the laboratory in Laois County Council to carry out extensive tests on our raw and treated water about 4 times each per year. The raw water quality indicator parameters include total coliforms, E. coli, pH, alkalinity, nitrates, to mention but a few. We also have a full water audit carried out by Dublin City County Council laboratory at least once per year. Slide 21 is an example of an extract from this audit, and this audit covers 85 possible contaminants in the water, and all of these are tested. And I'd like to give a shout out there to Mark Chalk. I saw him somewhere earlier on. Mark is the head of our laboratory in Laois County Council, and the service they give to our scheme is second to none. So thanks for that, Mark. Chlorine demand can vary rapidly, meaning that the amount of chlorine available to disinfect the water can change, putting effective disinfection at risk. Slide 22 is an extract from SCADA Host and illustrates a typical example of a day's readings from the reservoir chlorine monitor. Our caretaker also carries out several manual total chlorine and residual chlorine tests at random points across the scheme. This random checking also serves to back up the automated readings taken by the chlorine monitors at the pump house. We have also installed 2 water testing kiosks on the network and hope to roll out several more in the future. The caretaker and myself also always keep up to date with quality assurance training and other courses as recommended by the Federation. Standard operating procedures for dealing with a water quality issue. The Heath Group Water Scheme has prepared a response procedure for a quality issue which will enable it to effectively manage the incident, limit the consequences and provide a framework for implementing procedures which will ultimately return the system to normal operations. It is of vital importance to keep the membership of the scheme advised of the situation and to provide important information to protect public health. Several template documents have been set up and ready to issue to all members in the event of a water quality issue. Our text alert system would be activated to give immediate notification to our membership. This text alarm, while immediate in effect, would be followed up by a more comprehensive notification in the form of a formal letter of advice from the scheme to all its membership. Conclusion, you'll all be delighted to hear. Water is an invaluable life-sustaining force. Our scheme will continue to maintain, develop and improve its infrastructure and systems in the operation of its plant and network. We look forward to new developments and improvements in the water industry in the future and relish the opportunity to move forward with our suppliers and advisors. I would finally like to end by thanking several persons who help us on a daily basis to maintain our water quality. The Federation in particular, Barry, Roisin, Adrian, Paul and Julie, who were always available for advice, support and training. I would like to thank Laois County Council, Water Services and laboratory staff, our engineers, our suppliers and of course our board, in particular our hands-on chairman, Mr Noel Boyle. And I would finally like to thank our fantastic caretaker. I cannot emphasise how important it is to have a good caretaker. That's John Delaney, and I kid you not when I say the man has water in his veins. Thank you for your kind attention, and I hope that some of what I discussed today may be of help to you. Thank you.